Welcome students in the series of motion in a plane. Now we are going to start the topic linear momentum. So let's begin the topic linear momentum. Linear momentum is measured by the quantity of motion possessed by moving body. What is the mean of that? Like a particle have a linear momentum means if I'm taking a ball that consisting some mass, suppose mkg. If I throw this with velocity v after applying some force. Okay. So for this movement, like the person holding that ball, okay, and before throwing, this will be doing backward his hand. After taking the sufficient force, sufficient energy, he will apply that energy to convert that ball into motion. During all these scenarios, some time has been spent, and that time into the applied force by which motion occurs, that is nothing but our momentum. Now, two factor, if the mass is more, then the applied force will be more. Correspondingly, momentum will be high. Similarly, if the velocity of very high of the ball, that means force will be high, again the momentum will be high. Means momentum is nothing but mass into velocity. So linear momentum is the product of mass of the body and its velocity. That means vector p is equals to m vector v. Momentum is in vector quantity. So we are taking vector p and velocity also vector quantity. So vectorially we can say vector p is equals to m vector v, where m is the mass in kg of the body and v is its velocity. This product involving a scalar. Okay. Now we are going to start conservation of momentum. Conservation of momentum. If we have taken two balls like ball A and B, they both will collide only when the velocity of particle A is greater than velocity of particle B. Okay. After collision, three things emit. First, heat. Second, sound. And third, a spark, so we can say as a light. During collision, okay, these three things emit and after collision they will separate out. All these complete scenario, what is the conclusion of that? The particle's total momentum remains conserved. That means particle follows conservation of momentum. Conservation of momentum. Now linear momentum, as I told you, is a vector quantity. It has some direction as the direction of velocity because mass is in scalar term. Unit of linear momentum is SI. It's expressed in kg meter per second and Newton second. In the other terms, we can say in CGS system, CGS means centimeter gram second. Centimeter gram second. or we can say in a dian second. So dimensional formula for linear momentum is mlt minus 1, because it is nothing but the change in momentum, and change in momentum is always calculated as final momentum minus initial momentum. As momentum is a vector quantity who has a both like direction as well as a magnitude, the vector subtracted must be used to finding some change in momentum. Now moving ahead, some multiple choice question. Linear momentum is a product of mass and velocity, mass and acceleration, mass and speed, or mass and displacement. The correct answer for this question is mass and velocity. Next question is, what is the dimensional formula for linear momentum? mlt minus 2, ml minus 1 t minus 2, mlt minus 2, or mlt minus 1. The correct answer is mlt minus 1. Now for your convenience, I'll just want to find it out like how this will become. So P is equals to m into V. M, that means M simply. V we can write as a LT minus 1. So the dimensional formula for momentum is mlt minus 1. Okay. It is a meter per second. So for meter, that means length L, and for second, T minus 1. I hope it will be clear. Next, law of conservation of a linear momentum. So law of conservation of a linear momentum, in the absence of any external force, if we are not applying any external force, the linear momentum of the particle of the body remains constant. What is the mean of a linear conservation of a linear momentum? So a particle's conservation of momentum is a property that any particle has in which the total amount of momentum never change. Linear momentum of a particle is a vector quantity. Linear momentum of a particle is a vector quantity. Okay. As the simply momentum has, as I told you earlier also. So from this statement, student, the key point is simply a particle conserved only when the force is absent, and this time total amount of momentum like P1, P2, P3 never change. I hope this statement is very clear to you all. Okay. Next, one thing more after this line, we can say that like it is important to remember momentum of a system, not the individual particle. Okay. The momentum of the system, not the individual particle, is conserved. Means during conservation of momentum, complete system will be conserved, not individual particle is conserved. Okay. So the momentum of individual body of the system may decrease or may increase. the momentum of the individual bodies in the system may increase or decrease depending on the situation, but momentum of the system will always be conserved. So the second important thing is, as I told you, momentum of the system remains conserved, not individual particles. So the individual bodies of the system may increase or may decrease. Okay, it depends on the situation. Okay, and complete system will be conserved during conservation of momentum. If vector f is equals to 0, then vector p is equals to constant. From second law of motion, we can say like f is equals to delta p by delta t. So if f is equals to 0, delta p is equals to 0. Delta p is nothing but p2 minus p1, or final momentum minus initial momentum, is equals to 0. So p2 is equals to p1. That means momentum remains constant when the force is absence. One another thing, the linear momentum of individual particle cannot change. Okay, but the total linear momentum, okay, can change. Okay, the linear momentum of the individual particle can change, but total momentum of the whole system remains constant, as I told you earlier. Example of a law of conservation of a linear momentum. So recoil the gun, like if a stationary gun fire a bullet horizontally, then the total momentum of the gun and the bullet is 0 before and after firing. So what has happened in this case? In this case, there is no external force acting on that isolated system. Okay, so where there is no external force acting on the isolated system, in this case, the rate of change of total momentum remains constant. Okay, so this will be applicable when there is a no external force. So when there is no external force acting on an isolated system, the momentum remains conserved. So somewhere in sometimes in the examination, isolated system word came. Isolated means which one is not interacting with any other system. Okay, like for example, if I'm just taking like recoil the gun. Second example, according to this conservation of the linear momentum, m1 plus m1 v1 plus m2 v2 is equals to 0. Explosion. In an explosion, linear momentum is conserved if a stationary shell breaks into two fragments. Okay, they will move in the opposite direction with velocities inverse ratio of their masses. So if a shell is at rest, break into three fragments, the total amount of any two fragment must be equals and opposite, okay, to their momentum, which is of the third fragment. Like P1 plus P2 is equals to minus P3. Here we are also studying about some rest, okay, that initially we are taking a stationary shell, okay. Proof of conservation of a linear momentum. So let M1 be the mass of M1, M2 be the mass of two bodies like A and B, moving in the direction same along the straight line with the velocities u1 and u2 respectively. So these are initial velocities. Which velocities? Initial velocities. That's why we have taken u1 and u2. When they collide with each other, they are in contact with a small interval of a time, okay, which we are saying as a instant of a time. Which time? Instant of time. Their velocity changes v1 and v2, okay, because direction is changes and velocity is a vector quantity. So if direction changes, so immediately we are like bound to use the word velocity changes, respectively they get apart. Like this is a particle A, it's a particle B. Initial velocity is u1, u2. This is a situation of during collision. During collision. Before collision, during collision and after collision. Initial momentum of A is PA and the velocity is m1 vector u1. And initial momentum of a B, PB is equals to m2 vector u2. Final momentum of P prime A is m1 v1 vector. Similarly, final momentum of vector B for the B particle is P prime B is equals to m2 vector v2. The force applied on the A and B in delta t times is gives the change in momentum of A. So applying the Newton's second law, which is nothing but FAB is equals to P prime minus P prime divided by T. That means change in momentum. Final momentum for A is, it is nothing but final momentum minus initial momentum. So as I told you, final for A particle is what? M1 V1, okay, and initial is M1 U1 by delta T. And similarly for the B also, so the force applied on the B in delta T times will also gives the change in momentum, which is nothing but again final momentum which is m2 v2, initial momentum m1 v1 divided by again delta t. So from Newton's third law, FAB is equals to minus of FPA. Every action there is an equal and opposite reaction. Applying this, put all these value, we get like final momentum is must be equals to the initial momentum. If I just put this value here, m1 v1 minus m2 minus m1 u1 is equals to m2 v2 minus m2 u2. So what we can get, m1 u1 plus m2 u2 is equals to m2 v2 plus m1 v1. Simple formula we will get easily. That means total final momentum of isolated system okay, which is initially not perturbed. Isolated, as I told you, initially not perturbed. Perturbed means disturbed. Initially, which will be static, okay, is equals to the initial momentum. I hope it's clear. So the above equation is also expressed as in this form, as I told you. This law is applicable in elastic and inelastic collision. In inelastic collision or in elastic collision, the law of conservation of kinetic energy also applicable. Now moving some multiple choice question. The ball falls towards the earth. Which of the following is correct? If the system contains ball, the momentum is conserved. If the system contains earth, the momentum conserved. If the system contains ball and earth, the momentum is conserved. If the system contains ball and earth and sun also, then the momentum is conserved. So the correct answer for this question is if the system contains as earth. Okay. The reason behind a ball falls towards the earth. Okay. So earth is a whole we are taking as a isolated system. Earth we are taking as a isolated system. So in isolated system, that means they are not interacting with any other things. So the net force will be zero. We can say momentum is conserved. And ball is the small part of that earth. Rocket propulsion. So I hope you understand this topic. If you have any doubt, you just ask your doubts, students, in the comment section. Till that, take care, everyone.